All right, let's look at the section 1.6, Cartesian products of sets. All right, so let's look at the notation. So Cartesian products of set A and set B is just A cross B. Right? So this set is really the collection of ordered pair. So let's say use a parentheses, x comma y, right? Such that, right, first element x has to be in A and second element has to be in B, right? Then we basically list all possibilities. All right, so for example, let's look at a small example. All right, set A has two elements, 1 and 2. Set B has three elements, A, B, and C. So the Cartesian product of A and B would be, right? So it's going to be ordered pair, right? So we can use 1 for the first one, and we can use any of A, B, or C. So we'll try to list all possibilities. So 1 comma A, 1 comma B, and 1 comma C. And we can do the same with 2. So 2 comma A, comma 2 comma B, and the last ordered pair would be 2 comma C. Right? So this is the Cartesian product of set A and set B. And note that the cardinality of the Cartesian product is pretty easy to find. So here's the note. All right. If you want to find the cardinality of A cross B, right? Right. We know that the Cartesian product of set A is 2 because there are two elements, and also Cartesian product of B, the cardinality of B, sorry, would be 3, right? Then cardinality of the Cartesian product of A and B is simply multiplying the cardinality of A and the cardinality of B, right? So in this case, all you have to do is 2 times 3. That'll give you 6, right? So let's make sure there are 6 elements. Here's 1, 2, 3, 4, 5, 6, right? So it seems like this gives you the right number. All right. Then another example we see quite often is R2. You've seen R2 somewhere along the way, and R2 is really the Cartesian product of real numbers. So you can see that the R2 is really the shorthand notation for Cartesian product of R with itself. All right. So this is basically the xy plane. So this is xy plane. All right. So we can use use R2 as, let's say, set C could be something like collection of x comma y, and this comes from the Cartesian product, say R cross R, which is just saying that this is a point in xy plane, such that maybe give a simple condition, say x squared plus y squared is equal to, say, 1. All right? And you can probably recognize that this condition, this is just the equation for unit circle, for the unit circle. Right? So this set C is simply the graph of the unit circle. So we can sketch the picture quite easily. So x-axis here, and you have a y-axis here, and here's the origin. and it's gonna go through 1 here, 1 here, so maybe I should write that 1 and 1, and here would be -1, and of course here would be -1 too. So you would have graphs. So set C is a collection of points on the unit circle, which looks like this. It's not a pretty picture, but I think you get the point. Right? That's it. I hope that this was clear.